Hello, everybody. Mr. B here for another episode of our fraction series of videos. We're in video 7, and here we're going to revisit multiplication, and we're also going to divide fractions. So if you remember, multiplication is simply where fractions is simply where you multiply the numerators and you multiply the denominators. Let's see what this looks like with some numbers in it. 2/3 times 5/7. That means we multiply the numerators, 2 times 5. We multiply the denominators, 3 times 7. And our end result is 10/21. You might recognize that there's no common factors between the numerator and denominator. So this is fully reduced, fully simplified to lowest terms, this end answer. We typically want our answers to be fully reduced. Let's see a problem where we're going to have to reduce. So in this example, let's multiply our numerators, 3 times 2, our denominators, 8 times 9, and what do we end up with? 6/72. Certainly this is not fully reduced because both numbers are even, so we can divide in 2 into the numerator and the denominator at least. And if we do that, 2 goes into 6, 3. 2 goes into 72 36 times. Hey, and then we recognize, wow, 36 is still divisible by 3. 3 is divisible by itself once. 3 goes into 36 12 times. So the answer is 1/12. This is our fully reduced final answer. That's what we want. There's actually a way to, instead of doing the simplification at the end, working on what we're given to make it easier to find the answer. I want you to see an example where we do that. I'm going to use the same example here. So the main idea is that we're going to divide out or cancel common factors before we do the multiplication. What allows us to do this is, you can imagine if we wrote this out using the rule, we could then prime factor the numbers. 8 is 2 times 2 times 2, and 9 is 3 times 3. We see that we've got 3's that are canceling and 2's that are canceling, and that leaves the 1/12 again. But again, this is a little more complicated than what I want to show you can do. Notice that we could take either numerator number and either denominator number and look for common factors. So 2 and 8, right? Those are both divisible by 2. 2 goes into 2 once, 2 goes into 8 4 times. How about 3's? 3 and 9, right? 3 goes into 3, 3 goes into 9. If we divide 3 into 3, we get 1. We divide 3 into 9, we get 3. Now we're at the point where it's really easy to multiply. We have 1 times 1 for the numerator, and we have 4 times 3 for the denominator, and we're done. So that's another way to do the reduction on the fly before you even multiply. Let's do one that's a little, let's do another one like that. So do we see any common factors between any of the numbers in the numerators and the denominators? And I think, yeah, 15 and 35, they're both divisible by 5, right? 5 goes into 15 3 times. 5 goes into 35 7 times. Okay, we can't get any more factors out of that. But 12 and 16, those are divisible by 2 or even 4, right? Let's say 4. 4 goes into 12 3 times. 4 goes into 16 4 times. And now we don't have any more common factors to cancel. So now we just do the multiplication. The numerators multiply I'll write them out. We have 3 times 3 and we have 4 times 7. So we get 9/28 and we're done. That was a lot easier than, multiplying 15 and 12. That's going to be a big number, bigger than 100, right? And 16 times 35, that's a big number. And then we'd have to reduce, and it would be a little more complicated. But by simplifying along the way before we multiply, the problem gets easier. All right, let's talk about division now. So to do division, we're going to convert our division into multiplication. It's going to be very easy because we know how to multiply. It's simple. Here's the rule. And over on the left here, I'm showing two fractions dividing with a big fraction bar between them. What this means is this. We've got fraction A over B being divided by C divided by D. We write it like this. And what we do is we convert it to multiplication. You can see this You can see the multiplication symbol right here. But what's different? This second fraction is called the divisor. Can you see it's C over D when it's being divided? But when we convert to multiplication, we have flipped it over. We've gotten the reciprocal, as it's called, of that fraction. So instead of C over D, it becomes D over C. Then we multiply and we get the answer. So it's easy. We convert division to multiplication of the reciprocal. Sometimes we see the fractions in this double stack. This is called a complex fraction, but most often you'll see it this way. Okay, let's do an example. So we've got 2/3 divided by 5/7. We convert to multiplication by multiplying by the reciprocal of the second fraction, the divisor fraction. Okay, now it's multiplication. We multiply the numerators, 2 times 7. We multiply the denominators, 3 times 5, and we get 14/15. Easy, right? Division is super easy. We sometimes have to reduce just like we do with any multiplication. So keep an eye for that. Here's one where I've presented the problem as the division of two fractions, this double stack fraction. It's like a number divided by another number, though. That's how you should look at it. Let's write it with a division symbol like this. So the top fraction, 7/2, is getting divided by 3/4. Okay? From here, we convert it to multiplying by the reciprocal, 4/3. And hey, let's use our technique of simplifying before we even multiply. Can you see we've got a common factor between numerator and denominator of 2. 2 goes into 2 once, 2 goes into 4 twice. And now let's just do it in our head. We know we have to multiply the numerators. 7 times 2, that's 14. Multiply the denominators. 1 times 3 is 3. And there's the answer. All right. I think I've got another one here. This one, I want to show that basically that 8 and that 8 are canceling and that leaves 5/7. And if you don't believe me, let's see, can I remove that stuff? Yeah. Let's say we start here. We wrote it as 5/8 divided by 7/8. Then we would be multiplying by the reciprocal. Now we can clearly see we've got an 8 over 8. Those cancel, leaving 5/7. Okay. So we could have just said, those 8s cancel, and we have 5/7. Either way you do it, you'll get to the right place. All right, let's do one where there's a variable in the fractions. So this will be pretty easy, as you'll see. It's division. We'll convert it to multiplication of the reciprocal. So we flip over the second fraction. And now let's use our technique of looking for common factors between the numerator and denominator. Let's look for numbers. 15 and 21. Well, I see a common factor of 3 there. 3 goes into 15, 5. 3 goes into 21, 7 times. And then 32 and 40, we've got stuff there. What 4 would go in. 4 goes into 32, 8. 4 goes into 40, 10. But we still have even numbers, so we could go more. How about 2 now? 2 goes into 8 4 times. 2 goes into 10 5 times. And why don't we write down what we've got so far? We've got 5x to the 4th times 5. And then we have 4 times 7x squared. Let's think about the x's. We've got x to the 4th over x squared. Well, the 2 x's on the bottom will knock out 2 x's on the top, leaving x squared. What do we have now? 5 times 5, 25x squared. And then we have 4 times 8. It's 4 times 7, which is 28 on the bottom. I don't believe there's any common factors anymore. This is fully reduced. And that's the answer. Okay, that's it for this video. We'll see you in the next one.